Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 1 video where I will discuss about how to find the area of a trapezium. So this is in this video I will discuss the very fundamental formula to find the area of a trapezium. In subsequent few more videos I will discuss more about finding the area of different types of trapeziums, that is when different data are given. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel and if you are watching my video for the first time and if this video is useful to you, then I strongly suggest and request that you please support me by subscribing to my channel. And also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the part 1 video on the topic of area of a trapezium. Okay, so first to find the area of a trapezium. So we know that in a trapezium we have one pair of parallel unequal sides and the other one pair of opposite we have a pair of opposite parallel unequal sides and the other opposite sides are not parallel, non-parallel sides. Now to find the area of a trapezium we need fundamentally three information. First is the length of its two parallel sides and the height of the trapezium. Now what is the height of the trapezium? So the parallel sides of a trapezium are known as, each parallel side of a trapezium is known as its base. So we have a pair of one pair of opposite parallel sides. So in the figure 1 we have in the trapezium ABCD, AB is parallel to DC. AB is parallel to DC. We have AB is parallel to DC. So for this trapezium, the bases are, there are two bases, that is the pair of opposite parallel sides. The bases are AB and DC. Now what is the height of a trapezium? Height of a trapezium is the perpendicular distance between its two bases, that is the distance between the parallel sides. So in this trapezium ABCD, what will be, if we draw a perpendicular from the point B to the side, on the side DC, let's say this is the perpendicular, and let's say BE is perpendicular to DC. So BE will be the perpendicular distance between the bases AB and DC. So we will have okay, so we will have in this trapezium the height is BE. We usually denote the length of the height with the small h. So BE is a height of the of this trapezium. Also I can draw a perpendicular from A on the side DC. So let's say this is a perpendicular. So this will also be the height h. And also okay, so this is fine. So for this trapezium ABCD, where AB is parallel to DC and BE is perpendicular to DC, we have the bases are AB and DC and the height is BE, which we normally, the length of the height we usually denote by the small letter h. So if in these figures, with some figures, example figures, I am trying to discuss what are the bases and height of a trapezium. So for the figure 2, as we can see in this trapezium PQRS, we have PQ is parallel to SR. So bases, the two bases are PQ and SR. So what will be the height of this trapezium? I can draw from one end point from one endpoint of one of the parallel sides, if I draw a perpendicular to the other parallel side, let's say from Q, if I draw a perpendicular to SR, so this will be let's say this is T. So this is the height. QT is the height of this trapezium. So height will be QT. Now I can also draw a perpendicular from the point P on the side SR, but this perpendicular will lie outside the parallelogram. So if I extend the side SR, let's say I am extending the side SR, and if I draw a perpendicular from point P on the extended SR, so this is perpendicular, let's say this is U, so this will also be P, let's say this is O. So PO is also the height of this trapezium. So we can have PO is also an height of the trapezium. So basically from any we know that in a trapezium the parallel sides, each side has two endpoints. So from one endpoint of one parallel side, if I draw a perpendicular to the other parallel side, so that will be the height of the trapezium. So quite obviously I can draw four perpendiculars. In a trapezium I can draw four heights. I can draw four heights of a trapezium, that is from one endpoint of one parallel side to a perpendicular from one endpoint of a parallel side to the other parallel side. Since there are 4 points, there are two parallel sides and there are 4 points. From each endpoint I can draw four height of the trapezium. Okay. For this trapezium in the figure 3, as we can see, we have WX is parallel to ZY. So the two bases are WX and ZY. Now to draw the height, I can draw let's extend the side ZY. I am extending the side ZY, let's say this is E, and I am drawing a perpendicular from the end point W on the extended side ZY. So let's say this is perpendicular, let's say this is F, and this height let's say is H. So height of this trapezium will be WF. One height, I mean the height of this trapezium can be represented by will be WF. There can be this height, the height can be drawn by some other ways also, like I can draw a perpendicular from X to the extended ZY. I can draw a perpendicular from Z on the extended WX, and I can draw a perpendicular from Y from the extended WX. For example, if I let's say I will drop a perpendicular from the point Z, that is from the vertex Z on the extended side of WX. So let's extend the side WX, and let's say this is the perpendicular so this is perpendicular to let's say this is G. So ZG will also be the height of the trapezium. So GZ is also the height of this trapezium. Finally, the last figure is actually it's an isosceles trapezium, where we can see that AB, in this figure we have AB is parallel to DC, and we also have the two equal sides, the non-parallel sides are equal, that is AD is equal to BC. Okay, so bases clearly are AB and DC. These are the two bases of this trapezium. Now what will be the height from the point A? I can draw a perpendicular on the side on the other parallel side, that is DC. So this is perpendicular. Let's say this is H. So height of this trapezium will be, let's say, AE is perpendicular to DC. So height will be AE. Also, I can drop sorry, a height perpendicular from the point B on the side DC. This is perpendicular. This will also be the height of the trapezium, that is BF. I can also draw a perpendicular from the point C on the side AB. So let me extend the side AB. Now, if I drop a perpendicular from C, the vertex C on the extended side AB, this will also be the height of the height of this trapezium. So GC will also be the height of the trapezium. So I hope it's clear what are the bases and the height. A height is also known as altitude. Height or altitude and the basis of what trapezium. Okay. Now let's see what is the formula of the area of a trapezium based on the length of its two bases and the height or altitude. So in this figure we can see ABCD is a trapezium. This is a very general trapezium. You can see that AB is parallel to DC, and we have drawn the altitude or height. BF and BF and AE are both perpendicular to DC. So BAE and BF are both the bases, are both the altitude of this trapezium. The bases are AB and DC. So we have assumed that the length of the AB, the side AB is X, and the length of the side CD is Y, and the height be H. Then the area, the formula is the area of the trapezium ABCD will be half multiplied by the sum X plus Y multiplied by H. So X plus Y, this is X plus Y, this is the sum of the lengths of the bases, as X is the length of the base AB, Y is the length of the base DC. So basically the area of a trapezium is half multiplied by sum of the lengths of the bases and multiplied by height or altitude. Now how this formula is coming, let me prove this, give a very quick proof how this is coming, how this formula is coming. Now the concept behind finding the area of a trapezium is that we will divide the trapezium into rectangles and triangles, and will use the concept of the area of a triangle and a rectangle to find the area of a trapezium. So as you can see in this trapezium ABCD, we are seeing there are two triangles ADE, this triangle ADE, and we have the triangle BFC. Okay. Now, and also for both the triangles ADE and BFC, their altitude is H. Since AE is perpendicular to DC and BF is perpendicular to DC, the AE is the height. So as you can see in this trapezium has been divided into three figures. Two are triangles ADE, and one is the rectangle. So ABFE is a rectangle. Now okay, so YABEF is a rectangle. In quadrilateral, in ABCD, in ABFE, you will see that AE is parallel to BF. Why? Because AE is perpendicular to DC and BF is also perpendicular to DC. So if two lines are perpendicular to another line, then those two lines are parallel. So we have AE is parallel to BF. And now And also angle E and angle F are angle E, and also we have AB. AB is parallel to EF, and angle E is equal to angle F is equal to, they are both 90 degree. So this will imply that ABFE is a rectangle, where, so this will imply that EF is equal to X. EF is equal to X, as EF is the side opposite to as EF is the opposite side to the side AB, and the length of AB is X. So EF will also be X. Now we will first find the area of the two triangles ADE and BFC, and the area of the rectangle. And so the area of the trapezium will be the sum of the area of the two triangles and the rectangle ABFE. Okay. Now for reference, I need to, let me create a copy of this figure, so that while I am discussing, it will be easy for me to refer. Okay. So this is the figure. Okay. So now we see that, let's try to find so what is how do we find the area of triangle ADE? If we need to find the area of the triangle ADE, we need to know its base, that is, we need to know DE. Height we know, because height is H, height is AE. So let in triangle ADE, no, first let DE be equal to P. Let the length of the side DE be equal to P, and also let FC is equal to Q. That is FC, that is the base of the triangle BFC, is equal to Q. Now this will imply that DC will be equal to DE plus EF plus FC. Now what is DE? DE is P, and what is EF? EF is X, and what is FC? FC is Q. This implies, now what is DC? DC is Y. So Y is equal to P, Y is equal to X plus P plus Q. We will need this information later on. Okay. Now what is the area of triangle ADE? So area A1, let's say area of triangle ADE will be equal to, we know that the area of a triangle is half into base into height. So for the triangle ADE, it will be, the base is DE and the height is AE, which is equal to half multiplied by, what is DE? DE is P. We have assumed the length of DE be P and the length of FC be Q. So this will be half into P into H, as we have assumed that the altitude of the trapezium is H. So the altitude of the trapezium is also the altitude of the two triangles. Okay. So this is equal to PH by 2. Also, let's find what will be the area of A2 of triangle BFC will be similarly equal to half into FC into BF. This is equal to half into Q into H, and this is equal to QH by 2. And the area of the rectangle, area of rectangle ABFE is equal to AB multiplied by AE, which is equal to XH. Therefore, the area of the trapezium, ABCD will be equal to, let's say the area of the rectangle ABE be A3. So, the area of the trapezium ABCD will be A1 plus A2 plus A3, which is equal to PH by 2 plus QH by 2 plus XH. If we simplify this, this will be equal to, if I take H by 2 common from all the three terms, H by 2 common, I have P plus Q plus twice X. Okay, this is equal to sorry, H by 2 from X, twice X, I'm writing as X plus X. So, I have X plus P plus Q. Now, this will be equal to H by 2 X plus Y, because we know that X plus P plus Q is equal to Y. We have already have this, Y is equal to X plus P plus Q. So, we see that the area of the trapezium is H by 2 multiplied by X plus Y, that is half into altitude multiplied by the sum of the parallel sides or the sum of the bases. So, this is how the formula is coming. Now, this proof was done based on a very simplistic general figure of a trapezium ABCD. This was easy. Now, what if this formula half into sum of the bases multiplied by height will be the same irrespective of the shape of the trapezium. Whatever be the shape of the trapezium, for any trapezium of any shape, it will have two unequal parallel sides, and we can find the altitude, that is the distance between the two parallel sides. If we know this information, that is the length of the two parallel sides or the length of the two bases and the altitude, we can easily find the area, which will be half into sum of the length of the bases multiplied by height. Now, just for the sake of completeness, let's see how this same formula will apply for a trapezium whose shape is like this. That is, as you can see, if I draw a perpendicular from A in this trapezium, we are having in the trapezium ABCD, we are having AB is parallel to DC. So, and so the bases are AB and DC. So, and the length of AB is X and the length of DC is Y, and the height of the trapezium is H. Now, so we have drawn a perpendicular from B on the side DC. Let's say this is BF. So, BF is the altitude of this trapezium. Now, if we draw a perpendicular from A on this on the other side DC, we can see that the altitude is coming outside the trapezium. So, we have to extend the side DC. If we extend the side DC and then we draw the perpendicular AE on the extended side of DC, we have this. Now, let's see how we can find the area of the trapezium. Let me properly draw the extended side. So, this is the extended side. Let's say this is G, and we have AE perpendicular to the extended side DC. Okay. Now, so we can see that we have formed two triangles. Uh, mm, so the trapezium is ABCD. The trapezium is ABCD. I think it will be better if we draw the perpendicular from C to the side AB. Let's extend the side AB. Let's extend the side AB and we draw a perpendicular from the point vertex C on the extended side AB. So this is perpendicular. Let's say this be E. This be E. Okay. Also, now also we can let's extend the side DC also, and let's say this be T, and draw a perpendicular AF on the extended side of DC. Okay, now what will be the, so consider the triangle, consider now since you will see that since AF is perpendicular to DC and CE is perpendicular to AB, AECF is a rectangle. AECF is a rectangle where let's say we have to assume something. So let's say BE, the length of BE is equal to, let's say, P, let. So this is let. We are assuming the length of BE is equal to P, and FD is equal to Q. FD is equal to Q. So now we will see we have that AECF will be a rectangle where we will have AE will be equal to AE will be equal to AB plus BE. Now what is AB? AB is the one base of the trapezium ABCD, whose length we have assumed to be x. So this is x plus, and what is BE? BE is P. Okay. Also we will have and FC and EC. EC is the altitude of the so this will also be H. So EC and AF, these two will also be the height of the trapezium, and also BF. So EC will be H. EC will be H. Okay. Now so you can see that we have the rectangle AECF, and we have the two triangles AFD and BCE. So let's so the area of the trapezium ABCD will be the area of the rectangle, AECF minus the area of the two triangles, that is area of triangle AFD and the area of triangle BCE. Okay. Now, so area uh, area area, let's say A1 of triangle AFD is equal to half into H. The altitude of the triangle AFD is H multiplied by the base FD, which we have assumed to be Q. So this is HQ by 2. Similarly, the area A2 of the triangle BCE will be equal to half. The altitude of the triangle BCE is also H, that is EC, it is also H multiplied by the base, which is BE, and BE we have assumed to be P. So this is HP by 2, and the area of rectangle AECF is equal to, we will have AE multiplied by H, which is equal to, AE is X plus P multiplied by H. Okay. Now, let's say the area of the rectangle be A3. Therefore, the area of the trapezium ABCD, area of the trapezium ABCD will be equal to the area of the rectangle, that is A3, minus the sum of the area of the two triangles, that is A1 plus A2. This is equal to, what is A3? A3 is X plus P into H minus what is A1? A1 is HQ by 2, and A2 is HP by 2. Okay, so this is equal to X plus P multiplied by H minus HQ by 2 minus HP by 2. From here, if I take H by 2 as common, we have twice of X plus P minus Q minus P. This is equal to H by 2 multiplied by 2X plus 2P minus Q minus P. This is equal to H by 2 2X, now 2X plus P minus Q. Okay, this is equal to H by 2, 2X we are writing as X plus X, so you have X plus P minus Q. Now, what is X plus P minus Q? What is X plus P minus Q? Now, in this figure, what is X plus P minus Q? Now, please note that AE is also equal to, so we note that AE is equal to FC, as these are the two opposite sides of the rectangle AECF, and this is equal to, so since AE is equal to FC, we can say that what is AE? AE is X plus P. And what is FC? FC is, we have FD. So FC is equal to FD plus DC. So what is FD? FD is Q, and what is DC? DC is Y. So this implies Y is equal to X plus P minus Q. So Y is equal to X plus P minus Q, and in the result we have got this. So this is equal to H by 2 multiplied by X plus Y, since Y is equal to X plus P minus Q. So we are having the same result, that is the half into altitude multiplied by the sum of the length of the bases. X and Y are the length of the bases of the trapezium. Okay. So this was the proof of the same formula, where the shape of the trapezium is little bit different. Now let's for this I will leave the proof for this trapezium as an exercise. You can try to, let's say, so if the altitude of this, let's draw an altitude of this trapezium. So let's say if I extend the side AB, let's say this T, and I draw an altitude, that is draw a perpendicular CE on the extended side of AB. So this is perpendicular, let's say this be CE. So CE is the altitude or height of the trapezium. So try to prove that the area of this trapezium will also be area of trapezium ABCD will be equal to half into X plus Y multiplied by H, where H is the height of the trapezium, that is CE. I will not prove this. I think based on the proof of the figure 2, you can easily prove that for this quadrilateral, where as you can see, if I draw perpendicular, both the perpendicular drawn from B and A on the side DC, they will be outside the trapezium. In the figure 2, the perpendicular from B to DC was inside the trapezium, but for this trapezium, both the perpendicular from A and B on the side DC are outside the trapezium. So how will you prove that the area of the trapezium is still half into X plus Y multiplied by H, where H is the altitude? Please try to prove do this proof yourself. Okay. Now let's based on this very basic fundamental formula of the area of a trapezium, let's solve very basic and fundamental some example problems. So the first problem says that the length of parallel sides and altitude of a trapezium are in the ratio 2:3:4. If the area is 360 centimeters square, then what is the length of the longer parallel side? Okay. So basically, the ratio of the two bases and the altitude is given. So if I draw the diagram roughly, it will be something like this. Let's say ABCD is the trapezium, where AB is parallel to DC. So let's say BE is the altitude of this trapezium, that is the distance between the two bases AB and DC. Since the ratio, so it is given that basically it is given that AB is to DC is to BE is to BE is equal to 2:3:4. This is given. So we know that when we solve problems of ratio and proportion, if the ratio of some quantities are given and we need to find the value of those quantities, we assume the values of those quantities as some variable using some x as a multiple of x based on the based on each parts of the ratio. So let AB, since the area is given in, since the unit is in centimeter, so let's say let AB is equal to 2x centimeter, and let's say, so this is based on the ratio 2:3:4, and DC is equal to 3x centimeter, and BE is equal to 4x centimeter. Now this will imply the area of the trapezium, area of trapezium ABCD will be equal to half into altitude, that is half into the sum of the bases, that is AB plus DC multiplied by the altitude, that is BE. This is equal to half multiplied by what is AB? AB is 2x and DC is 3x and BE is 4x. This much centimeter square. If I simplify this, this will be 2x plus 3x is 5x. So we have 5x multiplied by 4x divided by 2, this much centimeter square. So this is equal to 10 x square centimeter square. Now the area of the trapezium is given to be 360 centimeter square. So we must have 10 x square centimeter square is equal to 360 centimeter square. If we ignore the units, we will have 10 x square will be equal to 360. So this implies x square will be equal to 360 divided by 10, that is 36. This implies x will be equal to root over 36, which is 6. So x is 6. So definitely the question is asking what is the length of the longer parallel side. So it is asking about DC, since as per the figure we have considered DC to be the longer parallel side. So this implies DC will be equal to 3x centimeter, which will be equal to 3 into 6. The value of x is 6. So this much centimeter, which is equal to 18 centimeter. So the length of the longer parallel side is 18 centimeter. So these problems are very fundamental problems based on the direct application of the formula of the area of a trapezium based on the length of the parallel sides and the altitude. Okay, let's see the next problem. This problem says that ABCD is a trapezium with AB parallel to DC. E and F are points on AB and CD such that AE is to EB is equal to 1:P and DF is to FC is also equal to 1:P. If the ratio of areas of the trapezium EFCB and ABCD is 1:3, then value of P is, we have to find the value of P. Okay, let's do it step by step. Okay, so E and F are points on AB and DC. So we can clearly see that it has given that the ratio of the trapezium EFCB. So we have to consider the area of the trapezium EFCB. Now since ABCD is a trapezium where AB is parallel to DC and E and F are points on AB and DC, obviously EFCB will also be a trapezium where EB is parallel to FC. Okay, and also see that okay, now let's draw so to find the ratio of the area of trapezium EFCB and ABCD, we need to know their length of their bases and the altitude. Now the altitude of the main trapezium ABCD and the altitude of the trapezium EFCB, they are same, because which is equal to the perpendicular. If I draw a perpendicular from B to DC, let's say E, let's say this point B, the perpendicular BE is perpendicular to DC. So let BE, that is, we will draw a perpendicular BE to a DC. Okay. So this will imply that BE is equal to height of trapezium ABCD, that is the main trapezium, and also the trapezium EFCB. Okay. Okay. Now we need to know the basis of the two trapezium. Okay. Now it is given that now let AE, let AB is equal to X, and let DC be equal to Y. That is, we are assuming that the length of the side AB is equal to, even though AB itself denotes the length of the side AB, just for easy calculation and easy reference of quantities, I am just giving a name X, or the value, giving the value X to the length of the base AB, and the value Y to the length of the base DC. Okay. If and so now it is given that AE is to EB is equal to 1 is to P. This implies that AE by EB is equal. Okay. Now from this ratio, we know that the ratio is given. We know that AE is to EB is 1 is to P, and we also know that AE plus EB is equal to AB is equal to X. From these two information, that is AE plus EB is equal to X, and the ratio of AE is to EB equals to 1 is to P, from the concepts of ratio and proportion, I hope you will understand if I say that EB will be equal to P by 1 plus P multiplied by X. Similarly, AE would have been 1 by 1 plus P whole multiplied by X. This is a very fundamental concept of ratio and proportion. Okay, we have this. Also, similarly, DF and FC. Similarly, it is given that also DF is to FC is equal to 1 is to P. DF is to FC. Okay, DF is to FC is equal to 1 is to P, and we know that DF plus FC is equal to DC is equal to Y. DF plus FC is equal to DC is equal to Y, because we have assumed that DC is equal to Y. Okay. Now from here we can say that FC will be equal to similarly P by 1 plus P multiplied by Y. Okay. So we have found the two bases of the trapezium EFCB, that is, one base is EB and the other base is FC, and we know that the altitude is BE. Altitude is BE. Let's say BE be equal to this be equal to H, let's say. So this is equal to H, let. Now area of trapezium, let's say the area of the trapezium ABCD, let's say this BA is equal to half multiplied by the sum of the bases, which will be x plus y, and the height which is h. Okay, and the area of trapezium, EFCB, let this be A1 is equal to half into we know it will be the sum of its bases are EB plus FC, EB plus FC, and the altitude is same. This is equal to half into what is EB? EB is Px by 1 plus P, and what is FC? FC is Py by 1 plus P. We have multiplied by H. This, after simplification, it will be half, there is no space left. Okay, so this after simplification will be half multiplied by P by 1 plus P multiplied by x plus y multiplied by h, and there is no space left. Okay. Now we have to find the ratio of the area A and ratio of the ratio of these two areas A1 and A. It is given that the ratio of the area of EFCB and ABCD is 1:3. 1:3. Where will I write? Now what is, let me write it very small. What is A1? A1 by A is equal to given to be 1/3. Now this implies if you do A1 by A, A1 is half into EB, A1 is what is A1? A1 is half into P by 1 plus P multiplied by x plus y into h, and A is half into x plus y into h. So as you can see, in both the area A and A1, half multiplied by x plus h multiplied by h is common. So A1 by A will be P by 1 plus P, and on the right hand side we have 1/3. If you solve this, really have no space to do this solving. Okay, let me okay, really sorry for this weird solution. Anyway, so this will imply, if we do cross multiplication, we will have 3P is equal to 1 plus P. This will imply 2P is equal to 1, and this will imply P is equal to half. So the value of P is half. Hence the correct choice is B. B is the correct choice. Okay, let's do the next problem. The next problem says that the area of a trapezium is 384 centimeter square. Its parallel sides are in the ratio 3:5, and the perpendicular distance between them is 12 centimeter. Then the lengths of the parallel sides are. We have to find the length of the parallel sides. So what is given? Area is given to be 384 centimeter square. Okay, the perpendicular distance between them is 12 centimeter. That is, height is also given. The perpendicular distance between the parallel sides in a trapezium is actually the height or altitude of the trapezium. So height is given to be 12 centimeter. So clearly we can from these two information, that is the area and the height, we can find the sum of the length of the parallel sides. Since we know A is equal to half, let's do one thing. Since the ratio of the parallel sides are given, let assume lengths of parallel sides are based on the ratio 3x and 5x centimeter, since the unit is given in centimeter. Okay, so this will imply that area A will be equal to half multiplied by the sum of the length of the bases, that is 3x plus 5x, and we have the height, which is 12 centimeter square. Now this implies A is equal to on the right hand side, if we simplify, it will be 8x multiplied by 12 divided by 2 centimeter square. This is equal to 48x centimeters square. Now the area of the trapezium is already given to be 384. So we have 384 centimeter square is equal to 48x centimeter square. If we ignore the unit, we have 384 is equal to 48x. So this implies x is equal to 384 divided by 48, which is equal to 8. So x is 8. Now the question has asked what is the length of the parallel sides. Okay, so this will imply lengths of parallel sides are 3x or 3 are the ratio was the length ratio was 3:5. So we will have 3 into x is 8, 3 into 8 centimeter, and 5 into 8 centimeter, which is equal to 24 centimeter and 40 centimeter. So the lengths of the parallel sides are 24 centimeter and 40 centimeter, and hence the correct choice is A. Okay, let's do the next problem. So we have a figure. It is saying ABCD is a quadrilateral where AB is parallel to CD. AB is parallel to CD and BC is perpendicular to DC. Okay, the side BC is perpendicular to the side DC, and BC is equal to 120 meter. DC is equal to 50 meter. If area of triangle ABCD is 4800 meter square, find length of AB. Find length of AB and the ratio of area of ABCD and triangle BDC. So clearly ABCD is a trapezium where AB and DC are the parallel sides, and of course BC is the altitude. Since BC is perpendicular to DC, it is also the perpendicular distance between the parallel sides AB and DC. Okay, so AB, we know that AB is parallel to DC and BC perpendicular to DC implies height of trapezium ABCD is equal to BC. The height of the trapezium ABCD will be equal to BC. Okay. The area is given. Okay, and we have length of one parallel side and the altitude. Okay. So area will be equal to, we know, half multiplied by the sum of the bases or the sum of the parallel sides, that is AB plus DC, and the height, which is equal to BC. This is equal to half multiplied by AB we do not know, so this will be AB, and DC we have 50, and BCB it is given to be 120. So this much meter square. Okay. This is equal to, if we simplify, do a little bit of simplification, 120 divided by 2 is 60. So 60 multiplied by AB plus 50 meter square. This implies, now what is area? Area of the trapezium ABCD is given to be 4800. So we have 4800 meter square is equal to 60 multiplied by AB plus 50 meter square. If we ignore the units meter square, we will have 4800 is equal to 60 multiplied by AB plus 50. This implies, what is AB plus 50? This will be 4800 divided by 60. This is equal to 80. So this implies AB is equal to 80 minus 50. Okay. So 30 meter. AB is 30 meter. Okay. It is asking find the length of AB. So AB is 30 meter, and it is also asking the ratio of the area of ABCD and BDC. The area of the trapezium ABCD is given to be 4800. We have to find the area of the triangle BDC. Now for the triangle BDC, DC is the base and BC is the height. So area, let's say this be A2, let's say this be A1. Area of triangle BDC is equal to half multiplied by DC multiplied by BC. So for the triangle BDC, DC is the base and BC is the height. This is equal to half multiplied by, what is DC? DC was given to be 50. So 50 multiplied by BC is the altitude, which was 120 meter square. And we already know that area A of trapezium ABCD is equal to 4800 meter square. Now what is this? What is A1? If we simplify A1, it will be 360 30, so 3000 meter square. Okay, so we have A1, the area of the triangle BDC is 3000 meter square, and the area of the trapezium ABCD is 4800 meter square. So we have to find the ratio of ratio of area of ABCD and triangle BDC. So A by A1 is equal to for A by A1 is equal to 4800 by 30,000. This is equal to 48 by 30 This is equal to 6 8 by 5. So this implies A is to A1 is equal to 8 is to 5. 8 is to 5. Okay. Let's do the next problem. I think this is the last problem. Okay. ABCD is a trapezium with AB parallel to DC. BG is perpendicular to DC. Okay, so BG should be the height of the trapezium, maybe DC or altitude. EF is parallel to AB. Okay, so EF is also parallel to AB. Okay, AB is 5 meter, DC is 20 meter, EF is 10 meter. If the ratio of area of ABFE and ABCD is 1:4, then find BH is to HG. BH is to HG. The ratio of area of ABFE, okay, and ABCD is 1:4. Okay. Okay. So what is area? Area of trapezium. Now, as you it is clear that ABCD is a trapezium. AB is parallel to DC, and EF is also parallel to AB, which means that EF is also EF is parallel to AB. So clearly, ABFE will also be a trapezium. So area of trapezium ABFE. Now, before that, we need to understand that EF is parallel to AB and AG and BG is perpendicular to DC. This will imply that this will imply that BH is perpendicular to EF. EF is parallel to AB, which means that EF is also parallel to DC. And if BG is parallel to DC, if BG is perpendicular to DC, then BG will also be perpendicular to EF, because EF and DC are parallel. EF and DC are parallel because EF is parallel to AB and AB is parallel to DC. So BG is perpendicular to EF, which means that BH will also be perpendicular to EF. Okay, so this will imply that height of trapezium ABFE is equal to BH. So now the area of trapezium ABFE, let's say this be A1, will be equal to half multiplied by the sum of the bases, that is AB plus EF, multiplied by the altitude, which is BH. Okay. This is equal to half multiplied by what is AB? AB is given to be 5 meters. So 5 plus what is EF? EF is given to be 10 meters. So we have 5 plus 10 multiplied by BH, this much meters square. This is equal to 15 by 2 multiplied by BH meter square. So this is the area of the trapezium ABFE. Okay. Now what is the area of trapezium ABCD? Area of trapezium, but before that, let us find what is the altitude of the trapezium ABCD. So altitude height height of trapezium ABCD is clearly BG, because BG has been drawn perpendicular to DC. So BG must be the height of the trapezium ABCD. Now what is BG? BG is BH plus HG. BG is equal to BH, BG is equal to BH plus HG. BH plus HG. Okay. So the area of trapezium ABCD will be equal to half multiplied by the sum of the bases, that is AB plus DC multiplied by BG. This is equal to half multiplied by what is AB? AB is 5 and DC is, what was DC? DC is 20 meter. So this will be this much meter square. So 20 multiplied by what is BG? BG is BH plus HG. This much meter square. This is equal to, if we simplify, we have 25 by 2 multiplied by BH plus HG meter square. Let the area of the trapezium ABCD be A. Now, so this implies that it is given that the ratio of the area of the trapezium ABFE and ABCD is 1:4. So it is given that A1 by A is equal to 1/4. So this implies, what is A1? A1 is 15 by 2 BH. So we have 15 by 2 BH divided by what is A? A is 25 by 2 multiplied by BH plus HG is equal to 1/4. Okay. Simplifying the LHS, we will get 15 BH, that is 15 multiplied by BH divided by 25 multiplied by BH plus HG is equal to 1/4. If we do cross multiplication, we will have 60 BH is equal to 25 multiplied by BH plus HG. On the right hand side, after simplification, it becomes 25 BH plus 25 HG. Okay. This implies, moving the BH term to the left hand side, we have 60 BH minus 25 BH is equal to 25 HG. Further simplifying, we have 35 BH is equal to 25 HG. হয়েছে তোমার? আচ্ছা আচ্ছা, আমি দেখে আসবো, পরে করিনি, ভিডিও করছি, আমি দিয়ে আসবো। আচ্ছা হ্যাঁ ঠিক আছে। আর ঘাসটাও পরিষ্কার করতে হবে, ঘাসটা, বাগানটা। Okay. So we have 35 BH is equal to 25 HG. So this implies we have to find the ratio of BH and HG. So this implies BH divided by HG is equal to 25 divided by 35. This is equal to 5/7. So this implies the ratio of BH and HG is equal to 5:7. So the correct choice is C. C is the correct choice. Okay, so sorry, these were few problems based on very fundamental application of the area of the trapezium, that is half into the sum of the bases multiplied by altitude. Now, for solving some problems, you have to be good at visually interpreting the given figure. You have to visually understand what are the bases of the given trapezium, what are the altitudes, and then you have to apply the formula. In the next video, I will solve the problems of exercise from the textbook of author R.S. Aggarwal. The exercise, I will solve the problems of exercise 18A. So this is chapter 18, area of a trapezium and a polygon. I will solve the problems of exercise 18A, and then I will discuss about how to find the area of a polygon, that is regular polygon and irregular polygon. And also I will while I will discuss all these concepts, I will also prepare some assignment problems on the concepts which I am covering on this chapter, that is area of a trapezium and polygons. So there will be assignments coming, and so once this chapter is complete, so I am currently discussing the chapter area of a trapezium and a polygon from the textbook of author R.S. Aggarwal. So after covering the next topic, that is area of a polygon, I will solve the exercise problems of exercise 18B and then 18C, and finally I will solve the test paper 18. So to discuss the area of polygons, I will probably split that topic into 2 or more videos. So please stay tuned for these videos coming soon. If this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. I will end the video here. Thanks for watching, and until the next video, take care and bye.